Hey everybody, this is Larry. This is day 24th of the August Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Yay, today's complex number multiplication. Okay, I usually start these live, so if it's a little bit slow, just watch it on a faster speed or something like that. Okay, let's see. Okay, complex number, we turn a string. Okay, so this is pretty straightforward. If you have any questions about complex number, probably just Google it or read up on the Wikipedia. Maybe this even goes to it. Yeah. I don't think there's anything tricky about this. You just have to do it. I would say though, one more thing is that in Python, there is a library about this. There's definitely a library on complex. I think it's just complex maybe. Like, let me see. Let me play around with that real quick. But I haven't used it in a while because I haven't done math. Oh, that requires it for a while, but let's see. Let's just run this just to see. So yeah, so you can kind of see it actually, and I mean obviously this isn't the exact input output, but actually I guess this is the output but not in the expected format. So you can definitely do that. Yeah, I mean obviously if you get this on an interview, you wouldn't. I think they expect you to do more than a. They expect you to do more than this, but yeah. Okay. So I think this then becomes a parsing problem as well. And the format is that the last character is always an I, there's a one plus, and only one plus, though it could be a negative before that. So, okay. So let's play around with that. I don't know if the complex, I wonder if you can pass in a string to complex. There's probably a parser library somewhere, but that said, let's see. We can do this ourselves. So just parse imaginary of s. Let's just do a split based on the plus, and yeah. So then now you have real imaginary is equal to this, and we want to make sure. We just parse this. We want to get rid of the last character, which is I, which is why I have it like this. And then we just return, say, a tuple. But I would I would use a name tuple for this if I was doing more production level Python. But of course, you can also say that if I'm doing more production level Python, I would not create my own complex class, because that seems like a very common. It's not a common thing, but common enough that someone would have done it for you, right? It's like big int and all that stuff, like fast Fourier and transform. Someone has done it for you. You don't have to do this. So that said, you still, especially if you're interviewing or something, try the best you can. So there you go. Okay, so now we just parse imaginary number one. So let's just call it I1 maybe. Maybe a terrible name. Number two. Did I spell that correctly? I feel like I'm doing one of those things where you see the same word 5 times. You're like, wait, this word now looks weird. Okay. So how do you do this? So I actually don't remember how to, I mean, I don't remember off my head how to do it because I know how to prove it, right? Like I know the principle. So yeah. So I can just double check and I don't have to look at it. So this times this, you have A times C plus A times D. I mean, I did it the other way, so I guess, well, I'll do the schoolyard way. Maybe that's a little bit more visual because I just went up left and right. So we have this component times this component, which is B times D times I square. And then D sub times I times A, so that's A times D times I plus this thing. And then now you have C plus BI, so C times and then A times C, so that's A times C, something like that, right? I mean, I know my visuals are not that good. Maybe I should have used the whatever, but okay. Then if you line them up, is just A times C plus A times D plus C times B times I plus, or I guess minus B times D. And of course, now we group them together, and there you have it, right? So that's the formula. I didn't, I mean, like, the only thing you have to know is that I squared is equal to -1, and from that, you can do this, right? Like, I'm not trying to be like, oh, you should memorize this. You should not memorize this. In fact, is how I would teach math. It's just, now you can prove it in like 10 seconds or 20 seconds. Why would you need to remember stuff? Remember more important things like, your mom's birthday or something. I don't know. Okay, so then now, okay, so now let's get it started. So that's just times I2 of 0. And again, if you use a name tuple, this would be more readable, because if you use a name tuple, you have something like .real or something. Maybe let me do that. Let me the reason why I don't use name tuple is because I don't remember the syntax. Let me look it up real quick, and then that'll be a good learning lesson. I used to in production code, I use it all the time, to be honest, but I haven't done Python production in a while. So hang on. Okay, do I have to? Okay, maybe I don't. Okay, I just call it complex number, and then you have what's it? Real, imaginary, I can't even spell imaginary. And then this is just complex. Let's go to this, right? And then here now we can return, yeah, and then now this works in theory. Let's see. Okay, so it does. Yeah, so this looks good. Okay. I think you can even now, to be honest, in theory, in this case, you probably actually wouldn't have a name tuple, to be honest. Like if you want to write clean code, now that I'm thinking about it a little bit more, if you want to write clean code, then this wouldn't be a name tuple. This would just be a class, and this would be part of the thing. And then you also have a toString function that allows you to do that. But multiplier, you would overload it, but that's okay. For now, this is just trying to keep it a little bit complex is a thing I forgot. Okay, just call it SN. Yeah, so this is just S dot, let's go at C for complex maybe. Dot real plus C dot imaginary. I'm doing that thing where I can't spell after a while. So yeah, and you can for the purpose of this problem, I guess you can and just do it in line, but I would actually also just have another function about it. So okay, so now we have a new complex number. So answer is equal to complex number of this thing minus I1 dot imaginary times I2 dot imaginary. I can't, man, I gotta come up with a better thing for it, so I can't spell today. So I1 dot real times I2 dot imaginary plus I2 dot real times I1 dot imaginary. I don't write this very often, so that's why I'm very slowly and awkwardly. But yeah, and then now just toString answer, and then there you go. So it becomes a parser and a stringifier thing. This looks okay. Are there any weird zeros? Yeah, okay, thanks. I guess we can just do zero stuff. Maybe. I think that's the thing that I may think about. Okay, this looks good. Unless there's some weird test case, I don't know. Actually, I want the answer. Okay, I was gonna say I want an answer to be negative just to see what I print, but that looks okay. So okay, let's give that a go. Cool. Yeah. So this looks good. What is the complexity? I mean, this is just two parsers, one to string, and a couple of multiplications. So this is effectively constant, assuming constant size integers and so forth. So yeah, that's all I have for this one. I don't know if I have anything to go over for this. Like I said, you can prove this from first principle, so I don't think math should block you. And if you've never done complex number, then the I square thing may not come as intuitive. I don't know if that's a thing people learn commonly. So, or like you may be a little bit unfamiliar, but you can also know, I know enough about complex numbers to forget about it, and you could Google it, I guess. But I still do this, so it wasn't like I just looked up the formula. Anyway, that's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. Have a great rest of the week, and I'll see you later. Bye bye.